Hello? Hello? Buzz? 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 Hello? You guys awake? Man, did we get up early. But, was that worth it? I got some news for you. Reworking your orbiter. Oh, very nice. Oh, very nice. You missed it? So, tonight's launch has a 70% probability of violation, with it going up to 90% tomorrow. Oh. Well, maybe this will help. Maybe this will help. Does that help? That's pretty neat. Link, please. Link, please. There you go. There you go. There's your footage. Let's see. Anything else floating around NASA's images? There's the rocket cam footage. Anything else? Well, we got a nice shot of the guy that is partially responsible for this entire thing. I can't believe that thing launched. You believe that? You believe that? That actually happened. They're coming from there around the pot. Hey, very nice camera.
Discovery, go at throttle up.
And then from there, with the views this morning.
Discovery, go at throttle up.
The views this morning, dudes, were just Black Horse in. Oh my god. I got nothing, dude. I would say think about the gravity of this picture, but I got to chuckle. Get a sensible chuckle. Just a the belly laugh, maybe? No? No? All right. The views were out of this world. Okay. All right. Kill him. Have spectator number 1 killed. Why isn't NASA showing this 24/7? I've been asking myself that question since it launched. Boosters edition. Yeah, Red Fox, that's been my problem with this the entire time, dude. That we're not seeing this. Any update from NASA after it went around the moon? Yeah, Red Wagon, everything seems to be good, man. Yeah, everything was on time, and just. Dude, I don't have anything to say. That is... What about their blog? Alright, I'm not going to lie to you. I don't follow their blog. Is that bad? Don't tell anybody, okay? Don't tell anybody, okay? I don't follow their blog. They say to follow the blog. I don't follow the blog. Man... Man! Why are you doing this? Fine. Blogs? Yeah. Yeah, there's a reason why I don't do that. Because it's 2022 and we don't need to follow. We don't need no stinking blogs. Blogs? Ooh. What's wrong with blogs? They're better than bad. They're good. Yeah. Okay, I'll give you that one. Yes. Cogs. Serious, we got to find a way to make a meme, a forced meme with cogs. Yeah, follow my cogs. You believe that? NASA has some what to eat? Oh, yeah. Yeah, exactly. The reason why... So check this out. Zeb Scoville, who's like a legendary NASA flight director, posted this. Check this out. Discovered yesterday that the 34-meter Deep Space Network dishes can handle greater bandwidth than previously analyzed, so this will allow more live video streaming and imagery downlink. NASA.gov will start carrying the feed at all times. Sorry, there will still be some gaps. I feel like crap after my wisdom teeth removal. Yeah. Here. Alright. Before we jump into KSP, check this out, dude. No evidence of that. Well, Zeb is not a liar. Red Fox, they'll get something. Here, you want to see something cool? Look at that picture. Look at the picture. What can Sawyer? You see it? This thing on? Hello? Can you hear me? Oh, yeah, Red, that's a good idea. So you guys see this? Look, I did a little more buffing out today, and I actually got at the factory paint. I've only shown you, like, screenshots of this, but I wanted to show this before we jump into Kerbal real quick. Look at this. See that? Look at that. Around the back. Look. Can you believe that? Freaking got the factory paint back. I buffed the spray paint right off. I mean, I'm not gonna lie, that kind of looks cool. But also, look at that. So, after the stream, before I took a nap, I took this and I buffed it with the detailer. And you can literally see your reflection in paint that was spray painted over. I got it right back to the clear coat and buffed it. Can you believe that? Look at this. We're playing Kerbal, dude. We're playing Kerbal. But yeah, I wanted to show that. Look. Now, don't get me wrong, we blew through around this dent down here. but it was a dent, so I'm pretty sure that was like that already, because if you look right at the tip of my finger, you can see a little bit of rust. So that means that was trapped in there. I'm not sure how we're going to pull this dent out either way. So check this out. Look. This was spray painted. Not bad, huh? Pretty good. I put it on the charger, and then I was like, nah.
Discovery, go at throttle up.
Doom was May of 97? Maybe. Flash! You're gonna need a bigger garage. Yeah, maybe. Nothing's working today, it's not your fault. You get sleep or you just been pounding coffee? A little bit of both. A little bit of both of those things. Anyway, let's jump into Burble. Do you own model trains? At my parents' house, dude? Yeah, sure. Artemis 1 trajectory. Dent visible in episode 1 of Scumbag Labs. Oh. Oh, yeah. Yeah, there it is. Oh, yeah. Well, look at that. Huh. Okay. Man, I wish I could get the truck back to this. I mean, we might get close. I got some of it. Dude. I was gonna say DOM, data manufacturers, May of 97. Yes. So that's what started this whole escapade. Fight those. I was trying to look at the manufacturing tag because I wanted to see what month it was manufactured. That stuff's cool. I think that's really neat. You know, it means something to me. So you get there, it's just a matter of how much time you put into it. Well, I mean, I did a little bit of math out. I did the math out, dudes. I was like, okay, so one can of brake clean can do about, I don't know, like maybe 2 square feet. All right, and what's the surface area of the truck? 100, 200 square feet. I don't have to paint the bed. The bed is by far and away the most surface area, right? Maybe, if even that, right? Say it's, let's just overestimate and say it's 200 square feet. 200 feet of like everything that I need to buff the paint off of, right? let's see. Brake clean is $5 a can, right? And that means, you know, if we do 200 square feet, you divide that by 2, right? So that's 100 cans of brake clean, right? That's not too bad, right? That's up. You're not going to get a paint job for that amount of money. 100 cans, so $5,000. 100 times 5 is not 5,000, Panta. Some more footage has dropped? Oh. If any of you guys can get a factory paint job for $500, please let me know. It's the shuttle operations manual. Soccer news, Senegal, Netherlands, 0-1. Okay. We got Wales a little bit later in the day. So, yeah. If you bulk order it, it might even be cheaper. That's right. Give me 1 second. Okay. 500 earlier you said 125, and because that was a gross overestimation, Bree. It's more or less going to be like 100, 120 bucks. That was way overestimating. I highly doubt the truck's total surface area is 200 square feet. I highly doubt that. Yeah, like highly doubt that. Is this it? Yes. Page 702. Awesome stream earlier this morning. Sad to say I fell back asleep during the backside and lost the signal. If you were there right at signal blackout, dude, it was worth it. So we got some new media coming from Artemis real quick. Huh? Dude. Oh, that's pretty good. What's that weird asteroid in the background? I don't know. Must be a space station or something. You can get a 55-gallon drum of brake clean for like $500. Dude, Sawyer, honestly, that stuff comes off real quick. Just a little and you can get probably about this much surface area. Like, I was doing some rough estimations. The point is that even if I paid like retail price for brake clean, it's still going to be way cheaper than any paint job ever. Now, don't get me wrong. There are some parts of the top of the truck that are bare metal. Yeah, getting the spray paint off exposed a lot of bare metal up there. You can't really see it because it's buried in the silver paint on the top, right? But there is some bare metal up there, which does suck. But I do have some Oxford white touch-up paint, and yeah, we'll buff. I mean, it's white paint. Who cares? Find the spot. We'll find the spots, and you know, we'll sand down and scuff it up, and then we'll smooth it over, and I'll wet sand it and cut and buff it. Easy peasy. That's no moon. Yeah, I think it is the moon, Novus. It's too big to be a space station. Too big to be a space station. No, Adino sign. No. Artemis 3 is going to a completely different orbit. This is an orbit that more or less stress tests all the onboard systems. It's not going to be the final orbit that it's going into. Update from the JAXA landing CubeSat thingy. They were unable to gain contact, so the landing mission is canceled. Shame. Yeah, they had a little CubeSat with an SRB in it, Hokey. Yeah. Dude. That's crazy. Artemis 1's trajectory. Oh, Chris Hatfield posted this. Let's see. Yep. Yep. And there it goes. Oh, that's so cool. Dude, come on. See what I mean? They sent it out. They sent it out where the moon was going to be. And because the orbital eccentricity was so high that the thing basically stopped, and then the moon pulled it in. And that's what we saw this morning. We literally saw it stop and whoop, it changed direction. Isn't that crazy? This is not free return. No, they had to do a slight correction burn near Parallune, Chris. And then it's going to shoot it out. And look, if you notice how it's orbiting relative to the moon, see? It's retrograde around the moon. And then it's going to come back again, and what it's going to do here is another retrograde assist, right? And then they'll do another slight course correction and an ejection burn, and it'll boop, stop right there. Boop. Pretty crazy, right? Scroll a little bit. Tucker's comment. Who? Why not just do a slingshot around the moon? That seems easier. A free return trajectory? They want to test the solar panels, Ree. So instead of a free return, if you do this and do some slight course corrections, you can get it to stay up there for a week around the moon, right? You can get it to stay up there for a week around the moon using way less delta V, right? With the low energy transfers. Remember, low energy transfers means it's way more efficient. So you're not burning up all your fuel. This is using more of the natural gravitational effects instead of basically brute forcing against them like Apollo. Free return is boring, and they already did that. Well, I got some news for you. You're not gonna be too excited about Artemis 2 then. I got some news for you. You're not gonna be too excited about that. I got some news for you. You a photographer? I'm a combat correspondent. Oh yeah? Seen much combat? Well, maybe a little on TV. Artemis 2 is like Apollo 8. That's correct. Mm-hmm. Well, that's pretty neat. The backlighting is very nice. Woola bully. This is my friend, and this is his party. If there isn't a board, it turns red. Yeah, 18, better part of 18, Sam. They're gonna do a free return and then probably another little ways after that, it's going to do... then we'll eventually get there. It's going to take some time. But also, this is very much getting us back on the right track. You can simulate a rectilinear halo orbit in KSP? No. No lunar precession. Nope. Yeah, there you go. There you go, Caveman. That's a good way to say it. That's a good way to say it. Yeah, you know, that's pretty good. That's pretty good. Yeah, open the pod bay doors, Hal. Oh, dude, wait. Marcus House got some sped up. He did some sped up footage. Look. Bro, it's just like time zoom. Link now, please. Okay. All right. It's time zoom. Time zoom. Shauna said it's time zoom. It's time zoom. That's it. Any word on KSP 2? I stopped playing KSP because waiting. February 24th, 2023. That a good enough word for you? That's literally like 2 months away. Yeah. 2.5. Let's say 2.5. Take a peep at the Artemis section. Okay, what's this? What am I looking at? Oh, geez. Okay. Why such a delay? Gotta assess the data. Gotta make sure the vehicle did exactly what you thought it was going to do, Yankee. That takes time. The first Apollo missions had this much of a gap between them, dude. You can scale up later. Look at Apollo 4 and Apollo 6 were pretty damn far apart from each other, dude. And that's even further apart from Apollo 8. Actually, well, Apollo 8 was a little bit closer, but you get the idea. We got to scale. The big gray ball on your screen earlier. What was that? I think it was just a bug on the screen, dude. I understand that, but maybe I misunderstand the goals between 1 and 2. I understand that the interim components for Gateway will start flying up there, but 2 is still a moon flyby and test in Earth orbit, right? But they're still saying minimum May 2024 before that happens. No. Artemis 2 is not low Earth orbit. No, it's going to the moon. It's following Apollo 8's trajectory for the most part. Yeah. And then subsequently after 2, once we validate that the Orion is a crew-rated spacecraft, then we're in business. Then Artemis 3 happens. And then 4, and then 5, and then 6. The missions by the end of this decade will scale up to about 2 times a year instead of you know, once every like year and a half. That's a pretty sharp ramp up when you think about it. Now, personally, I think they're going to ramp up to more than that, but that's just me. The important part. Yeah, I don't know what... Yeah, I'm not sure what you're trying to get me to see here. Let's see. Okay. What? Oh. HLS ops starts about 10 months before Artemis 3. Yep, actually this, yeah, okay, now that I'm looking at it. What is SpaceX Heavy Launch Vehicle? Oh, that's Falcon Heavy. Okay, yeah, I get it. Esprit, Gateway, IHAB, yep. Also, Gateway is now net 2026. Ew. Yeah, it is what it is. Yeah, just give it some time, dudes. I wouldn't really look too much into those. Anyway. Oh, according to this, when we hit Artemis 2, once we hit Artemis 2, things start to speed up. They should be. I mean, you never know. It really depends on the data, to be honest with you. Hey, new to the stream, what's your background in space? Like, what got you into it? Started as just a fan, Bam Danny? Yeah, started as just a fan, dude, and then, you know, got into it, started playing Kerbal. Kerbal is what made the stream good, and now just sit here and commentate on spaceflight all day. Teach about spaceflight, you know, doing STEM outreach is really kind of my thing. Yeah, I still play Kerbal, you know, we're going to play KSP in a little bit, but yeah, it's good stuff, man. Fun times. Yeah, and cars, yeah. I have, attached to my streaming office, I have my trucks, and we work on cars and stuff, and even though that's kind of a side thing, it's mostly space and Kerbal. I did see that, Caveman, yeah, they found a chunk of Challenger in the ocean the other day. Yep. Yeah, space is just really, really fun, dude. And yeah, I really am kind of anal retentive about like making sure that I know the right stuff, because if I'm gonna sit here and commentate on rocket science, I best be knowing what I'm talking about, don't you think? So yeah, just sit here and cover space, dude. Yep, that's right, Lemprod. Yep. Anyway, oh no, no. You playing KSP? Yeah, I'm gonna play in a second here. We'll play now. I'll load up Kerbal. guy sucks. He's a freaking terrible driver. It's just... That's... Yeah. Okay. Cool, I'll drop a follow. Interesting stream. Right on, Danny. Yeah. We'll play some Kerbal now, dude, and we'll, yeah. Sorry, I'm a little bit on the tired side. I'm usually a little more hype into it. I got up at 5 in the morning to watch the lunar flyby, which is just amazing. Yeah, Sirius, I'm not really... Yeah. They did McDirty, dude. I don't like that. I don't like that at all. Oh, you got gifted a sub, Danny. There you go. That's... just... Is Ricardo going to Red Bull, or did I mishear the commentary yesterday? I'm not sure, Mike. You're gonna trade Hulkenberg for... You're gonna trade Schumacher for Hulkenberg? What are you, drunk? I just don't understand. Mahawk had a decade of being a mediocre driver and is now back again. They gave Mick 1 season in a car that worked. Yeah, I know. I'm not sure how Gifted Sub works, but thank you. Awesome community you have. Yeah, Danny, they're alright. They're alright, dude. They're pretty damn good to me. I could see that bringing better results in the short term, but Haas really aren't future-proofing themselves. Yeah, that's gross. Is it now that I should tell you my coworker is friends with Kevin? You've just failed to mention this information the entire time, Zizep? Even though your boy did a Haas playthrough in F1 Manager and got Kevin multiple podiums, including winning at Coda? You just failed to mention this? Alright. Okay. I see how it is. Your boy led Kevin to the promised lands, indeed.
Discovery, go and throttle.
Hey, Jindex, 50-month resub. Thanks, dude. That Haas one, too. Yep. I was shocked as well when I found out they're friends. Yeah, Kevin's good people. I like him. I've actually liked him since he told Nico Hulkenberg to, you know, get bent. Yeah, get bent. So here, check this out, dudes. Let me get the tunage. Oh, man. Alright, so check this out. Let me just make sure that the fairings are working right. There we go. Yeah. Oh, yeah. Whoa, mods in my KSP? Yeah, it is. I just got some visual mods and that's about it. Believe it or not, this shuttle is stock. There's no modded parts in here. There is one. There's one caveat to that. I took the SRBs and gave them the proper amount of gimbal. I did edit the craft file for that, but that's the only thing. There's no mods in this. There's no modded parts. There is a modded part, but there's no mod parts. Does that make sense? Yeah, Panther, precisely. He told me Haas shipped the spoiler with glass mounted on top to use as a table when he got married. It's just in the basement. Yikes. This launches as a space plane? No. No, not at all. I work on stuff in here. I build stuff inside of the SPH. You managed to achieve a halo orbit in KSP. In stock KSP Nova Raptor? I very much doubt that. What's the advantage? Better camera, dude. I can do this with the camera. See this? So, wait, Nova Raptor, you achieved a rectilinear halo orbit in stock KSP. That's literally impossible. You need mods to emulate the rectilinear halo orbit. You're just in an eccentric polar orbit around the moon. Yeah, more precise camera controls in the SPH, Caveman, for sure. But yeah, we were working on the robotic arm. Yeah, sorry, Nova. I don't mean to be a jerk, but yeah, you need the you need to have that's the right way to say it. You gotta have N-body simulation, and you need lunar precession to be able to do it. That's not something that's in the stock game. Well, at least I got better comms now. Well, there you go. I've tried. I did it for fun once, RJ. I know full well you couldn't get it. Yeah, see, we put the robotic arm in. Kind of want to test the changes that we made to it, like the power amplifier, so, I mean, you know what that means. Yeah, RJ, yeah. When do you think Lewis will stop racing? Lewis will stop racing when he feels like it, dude. Yeah, when that is, don't know. I have no idea. Huh. Didn't seem to save that. Interesting. He still needs to drive for Ferrari. Yeah, where Formula 1 champions go to die. Yeah, that's probably right. Is there a command that explains this new save? No. Not really. See the news that we have, we get another Dane driving Mercedes. Earlier you talked about computers predicting the future location of spacecrafts. How good are they with N-body? Because let's be honest, it's not even just Earth and the Moon. I'm sure Jupiter has quite the impact on spacecrafts. Yeah, you need an inertial navigation system, or an inertial navigation. So hypersonic, you know the missile knows where it is joke? That's a joke about inertial navigation systems. All right. Anyway. Yeah, let's give this a launch and mess with this thing here. Do I have the overclock on there? Is that working? Yes, that's working. PBDS is set to 40. Save. All right. Let's just go over here. Want to do anything for payload work while you're up there? I'd prefer the same mass simulator And then once we prove that this is okay, we'll once we prove that this is okay, we'll start designing some payloads. I'll kind of admit at the same time, dude, I'm really tired. Yeah. In vacation mode. Not really in vacation mode so much, but yeah, I'm just tired. Waking up at 5 really screwed up my whole routine thing, so we'll see where it takes us, dudes. If I have to take a break and come back, then I'll take a break and come back. I don't know what to tell you. I took like maybe a 30-minute nap, Panta. Naps don't really help. They don't help me. They just make it worse. I don't know why I haven't learned that yet, but... Okay. For catch missions, couldn't you use the arm with the KMU? Why? I was up at 4 a.m. my time with you. First time ever seeing the stream. Right on, Hawker. All right. Here's the shuttle that I engineered, guys. I'm working on a new space shuttle for a new Kerbal save. I want to get one last Kerbal 1 save in before Kerbal 2 pops up in a couple of months. And we built this new shuttle for it. This thing... Watch. GLS is go for auto sequencer start. Onboard computers have primary control of all vehicle critical functions. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Booster ignition. And lift off. Go for roll program. Roll program complete. Roger roll. We got 9 tons of mass simulator. It's looking good here. Throttling back the engines for maximum dynamic pressure. And I've been finding that enabling the pitch controller here on the way up is really, really useful. It really helps with the rates. Boosted to the digits. Okay, stand by for maximum dynamic pressure. No, the pitch controller on the number 3 engine. We get max Q. Orbiter is ready for throttle up. Go and throttle up. Go and throttle up. Trees. Robotic arm validation test. Space trees. Yeah, man. Space trees. Everything's looking really good here. thrust tail off on SRB. On the SRBs, we should be getting to a separation here very quickly. There's the tail off on thrust. Hey, Varf, what's going on? Garage stretch brake at 4, Alex. Showing good separation. Have you scripted the shuttle yet? It has so much potential to set rendezvous, deorbit, re-entry, and landing. I haven't, Edokin. No. No, I haven't, dude. Out of all the things that Kerbal decided to overdrive, it decided to overdrive the sound of the Separatrons, because of course it did. That's not how channel points are supposed to work? Fine. We could take a garage stretch break right now, Bree, if you want. Wouldn't bother me. It's not like we're doing anything important. Yeah, see what I mean? Then do it after orbit. Remo enabled them without asking me. Okay, we are wings up. Yeah, spacephobic, I mean... Try, dude. Try to make it look good. Apogee is too high. Gotta burn down slight. Burn slight radial in. Stand by. Press for Miko. Mark, press for Miko. We've Miko confirmed. Commencing main engine shutdown. Stand by for separation of the external tank. Shuttle, no ohms 1 required. Welcome to space. Yeah, thanks for coming, Plankin. Yeah, it was a good time. Alright. Yeah, guys, I've flown the shuttle a lot, dude. That's why I'm good at flying it. I'm feeling really inadequate about now? Uh-oh. I'm sorry. Oh, the booster went a little far away that time. Uh-oh. And it's diverging. Oh, we're not going to be able to get that back. It's out of render range. Are you going to be nervous when it's mission mode? No. Why would I be? Well, that booster's going to be junk. With simulations weed, it has to be in the thousands. That's just maturing and understanding what your vehicle's supposed to do, dude. That's really, really important. Can you add a gas vent to the external tank? Yeah, probably. There we go. We got a good drogue. Good main shoot inflation. Guys, deploy! Please deploy! Oh, that was close. During the shuttle era, did they ever lose any SRBs post-separation, aka the chutes? Yeah, sometimes. Sometimes they lost segments, dude. Yeah. Yeah, it was a little bit of a moment. A little bit of a bruh moment. We really got to get the separation angle figured out. There we go. There's my nose cone. The nose cone is just fine. Cool. Where's the orbiter? There we go. How does NASA ensure the chutes don't fold on themselves and fail to open? Pack them the same way every time. You gotta pack them in a certain way so they deploy correctly. What do you mean pack? Fold them like a shirt. Yes, that's exactly what I mean. You fold the chute in a certain way, it's going to unfurl in a certain way every time, without fail. True story. Alright. Stand by for ohms 2. Orbiter maneuvering system firing 2. We got ohms 2. Oh. Are you gonna put a parachute on the tail like the real shuttle? No. Parachutes are dumb. The shuttle didn't need it to fly. They did it as a modification later down the road to make sure that it, so they didn't cook the brakes as much. Nah, I don't want to shoot. I don't need that. We have a white tank. So, it's got to be like the early shuttle mission, so no shoot. Stand by for ohm shutdown. Got a good shutdown there. Not pair of shoes, SpongeBob. Parakeet. Not parakeet, SpongeBob. Parachute. Paramedic. Okay. We are go for hamster. Go for hamster. PBDS controller is online and enabled. Go for on orbit. No, it's going to be a new save that's going to end up being a lot like my old mission mode saves from 2014. I figured that's what made Kerbal big when we played the Streamwiser, when the stream got big. So that's what we'll do. PBDS. Payload Bay Door System. That's NASA's name for it, not mine. You're gonna like what I cooked up here if you haven't seen this. I hated how the doors opened too fast, so I bound them up to a PBDS Cal controller to get them to open at the same rate as the real ones. Oh, you'll like what I have cooked up here, dude. Don't worry. Now we're talking. Alright, before we can do some operations here, we just need to zoom around. Time zoom all the way over here. I don't have any action sets necessarily for the arm. There goes the ET, and zip. It's gone. Just gonna get us in a nice circle orbit here. There we go. Alright, we're up at 100. There we go. Alright, so let's begin on board ops here. So we got to go in here like this. First thing we need to do is inside of the payload bay. Okay, I'm noticing something a little funky here. Servo power amplifier is not working on all the controls. So yeah, it is. That's weird. Oh, okay. Everything is updated. Alright, cool. So, let's just shut down the orbiter maneuvering engine so we don't accidentally trigger those. That would be bad. We don't need to do that. Last, please. I'm kind of busy right now, dude. Thanks, Sweet. Okay. The manipulator positioning mechanism is unlocked and enabled. We're going to move the arm into the outward position here. Preparations for on-orbit operations. The first 4 flights of the shuttle program, STS 1, 2, 3, and 4, were part of the orbiter flight test program. And then they moved to operational missions at STS 5. Yep, they were the only time 2 people were on the space shuttle. 1, 2, 3, and 4. Okay, the MPM is in the outward positioning. And moving to the outward position system. We're almost there. Okay, MPM is in the outward position. We are going to disable that, and then we are going to lock out the MPM controller mechanism. And lock out all those. Make sure they're in the open position. And they are. We are going to undo the rotating drive assembly that holds the arm in place. RDA is open. These are all real names from the arm. I actually went and read the manual because I'm weird. Okay, and the servo power amplifier is online and working. Okay, so let's do a little bit. No damping on that. I gotta adjust that. Let's do a little bit of this and move this out. Oh, wait, hold on. We have to unlock the arm controls. Arm controls are unlocked. Okay. This is the first overclock servo test. That's correct. Okay. Should be good to move the arm out here. We don't need that here. Arm is moving. Yep. Oh yeah, that's a lot more crisp movement, dudes. Servo power amplifier is working correct. And it's actually interesting because we have an overclocked Cal controller here controlling the servos. And it turns out that the real one has an amplifier. The real one has servo power amplifiers. So they have overclocked engines. So they can deliver... The amplifiers can deliver variable voltage to the motors so they can move them at different rates. Once again, all in the shuttle manual, page 700. Let's move that out to 45. Oh man, we are going to build so many cool things with this. Moving the latching end effector into the forward position. Something like that, Nova, yeah. Thanks, public. Your latest creation. What's that, Banana? Hey. Nice. Nice. She looks good, man.
Discovery, go and
Hey,
drop.
Waz. 41113 sub. Thank you. Yeah, Aiden. I'm thinking we should do something like that. Just taking in the shot in the dark. Will you by chance be building a replica of a certain 1980s space station concept? What? What's a space station? I don't know what that means. Bits and tips. What is space? Yeah, I don't know. I don't know what these people mean, Brie. Oh, we snapped it, so we gotta reset. We gotta reset our power actuators. Hold on. Cycle the power actuators. Power actuators are cycled. Okay. All right, let's do this. Pull it. I wasn't here for the construction of the arm. It looks amazing. Yeah, I think it's coming along, dude. New KMUs, maybe? I don't know why we would need those, but all right. I mean, maybe. I always thought it'd be cooler to do it right. Hell yeah, man. Has the torque of those motors affected the orbit? I've had the orbit rates up here every time, Zorbio. No, it compensates just fine, dude. The key is to just move them slowly so they don't over-torque the vehicle. That's all. If the shuttle had an expendable mode, would it be able to reach the moon? No. No, not even close, dude. Yeah. I've been messing with the rates, Zorbio. That's why we're trying to do this. Like, we could do it with RCS here, or I could just do it with the gyros. It has not screwed with the orbit too much. You just got to be careful. When you get a payload that's... When you're hanging a payload this far outside of the payload bay, the payload has insane moment over the vehicle, and it does like to move around. You really have to be careful with what you're moving. Yeah, Wiser, it's gonna be good, man. Alright. I'm working with overdriven motors, S-Master. We have servo power amplifiers on the arm, overclocking the cows to see if we can move this thing around a little bit better. It seems like that G00 hinge down here really needs a high overclock. So what I'm gonna do... I don't know. Okay, that's the right one. What I want to do is really beef up the controller just to see what happens. Man, even with all that, it's still... That thing is still just moving around up there. Alright, let's dump it. I don't like how the arm moves around like that. I wonder how they were able to overcome this. It's possible that it's in a feedback loop with the SAS. Here, let's try using the RCS to center. Find control. See, it's just kind of... Why do I have it hanging out here? To put maximum stress on the arm is why I moved the payload as far away from the shuttle as I could. They really didn't try... They tried to make sure that any payloads that you're grabbing weren't too far away from the shuttle payload bay like this. Either that or it would hand it over to another vehicle, because this is putting a lot of stress on that arm. Gotta remember, putting more stress on the arm here, right? Putting more stress on the arm is going to end up making you use more electrical charge, and that could literally shorten the mission duration if you're not careful. Not that that ever happened, at least to my knowledge. See how much she's moving around? I really don't like that. Okay, go for release. Yeah, we have to mess with the traverse rates, dude, but I'm not sure how to make... We could have the controls interpolated via a cow controller, and that could slow the traverse rates down, because even a 1 traverse rate is going to introduce insane feedback. Okay, let's maneuver away. Okay. Let's go for Stowe. What was the reason for streaming today? Are you AFK later in the week? Yeah, drummer. Brimo and I are leaving for Detroit on Wednesday morning, so it's only today and tomorrow this week, dude. It's kind of a vacation week. But with Artemis and whatnot, I didn't really want to go too crazy with that, you know what I'm saying? Yeah, thanks, man. Okay, the Arb is moving back into stowed position.
Discovery, go at throttle up.
Happy Thanksgiving week. First station module or just testing? We're just messing around. Are you adding the crew egress model? It already has an egress model. I have an airlock built in. If you're talking about the docking array and stuff, yeah. Yeah, sure. Yeah, Aquilix, I got you. Okay. No, Pythos. Okay. Stand by for final arm stowage. And we should re-enable the RPS locks here. She's locked. Okay. Sweet. Locking out all systems. Okay. All ARM system components and servo motors are locked. Servo power amplifier is at 0. Okay. Unlocking the manipulator positioning mechanism. MPS is going to move into the stowed position. All 4 hinges are unlocked. We're going to reverse the cow controller, enable, and play. Can you store values for a stowed position in Cal and play a stow arm routine? I could, Aqualex, but honestly, all the automation for the arm is going to take too long. I could develop an entirely automated system with Cal controllers to use this, or we could just use it. I know. I don't have the time. Seriously. Kerbal 2 comes out in 2.5 months. Not enough time. So we can either add it as we go, or just say screw it. Okay, manipulator positioning mechanism is in the stowed position. We're going to lock out all the motors. Motors are in the locked out position. Disabling the manipulator positioning mechanism. Maneuver. Close the payload bay doors. Maneuver. That's a pretty good screenshot right there. Maybe over here, maybe just angle it a little bit. There we go. Maneuver. Do 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 do. Maneuver. Do 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 do. Okay, we're closed. Cool cutaway of the European service module. I saw WW actually linked a thing here, Novus, that actually was pretty freaking cool. Right here. Yep. It's on the processing stool, which is kind of funny. Oh boy, the Callisto Protocol. Oh, Epic Games Launcher. Bye-bye. Yep. And 204 MMH. High purity hydrazine. Yeah, you know, for that purity. Boost. Alright, let's bring her down. That thing, dude, that thing is freaking cool. It's impressive what this thing can do, man. It's just damn impressive. Okie dokie. Okay, we're going to add a maneuver. Maneuver node 1. Open that up. And we need a 292 argument of perigee. That's the magic number. 292 argument of perigee at 60 meters a second. Okay, we are keying in our deorbit burn. Shuttle is go for deorbit operations. We're going to re-enable the orbiter maneuvering system. Which is actually funny because the orbiter maneuvering system, you see this thing right here? You see this? See this little nacelle that's on the back of the shuttle? That quite literally is that. Yeah, that's right. The Europeans did assemble it, and it is derived from an ATV service module, but all the internal components are very similar to a shuttle OMS pod. True story. Even has the same engine. And when I say the same engine, I mean the engine that is up there on Orion right now. The AJ-10-190 that's on the back of that flew on in the shuttle program from 1984 to 1984 to like 2005, something like that. Yeah, it's a shuttle engine. It's the closest part of a space shuttle that ever got to the moon. Yep. I don't know how to feel about that, but hey, whatever. At least it's not for all mankind the way they did it. The way they did it was kind of dumb. It flew on a bunch of different shuttles. Yeah, the service module from Orion is basically a shuttle OMS pod. It's one of those things. True story. But it's very, very highly modified. But even in some cases, it's using the same dang parts. The same dang parts. Okay. Isn't it also derived from the Apollo CSM engine? The AJ-10? Yeah. It's not the same as what you'd see on an Apollo capsule, but it's close. Yeah, same design. Just the AJ-10-190 is modified for the shuttle. Okay, I doubt very much that a 60 meters a second burn is going to take 1 second, but hey, whatever. So the ones that are on the shuttle are they're AJ-10-190s. The ones that are on Apollo, the ones that were on Apollo are not 190s. I forget what they're called. Okay. We are standing by here for a deorbit. Actually, I said 292 was the magic number. It's really, once we get into the right spot, it's actually, yeah, it's actually like 300. Okay. All right, so we have the arm in the stowed position. KRAKEN tech is what's holding this thing in. For the Kerbal players, I used KRAKEN tech and actually hybrid tech to hold this thing together. See that antenna right there? And see the 2 thermometers that are holding it? It's KRAKEN tech. But I had a crazy idea. What if we just toggle same vessel collision to make a locking mechanism? So what happens is when I release the arm to go and move it, we hit an action group and it shuts off same vessel collision on the antenna and it pops the arm out. So the arm can move away. But anybody that messes with the robotics in KSP knows that they're a noodly freaking mess. In fact, we just saw it when I was messing with it a second ago. They're a noodly freaking mess. Kraken Tech's going to hold that thing in place, baby. When you look at the ohms for the shuttle, there are 2 long tanks and 2 spherical ones. Is there more oxidizer or fuel for it? So the 2 sets of tanks, one of them, actually there's 3 if you really want to know. There's 3, well, actually, here, you know what? Before we get to that deorbit burn, I will show you this. So shuttle, boosted ignition, shuttle ohms pod. Okay, so the Orion system uses something very similar. So if we're looking at the ohms pod, this is actually a perfect picture of it. So check this out. You have 2 tanks here, 2 tanks here, right? Liquid fuel oxidizer, liquid fuel oxidizer. So why have a big tank like this? Well, okay, so this liquid fuel and that oxidizer engine go to the AJ10-190. They go to the AJ10. This liquid fuel and that oxidizer motor, or oxidizer tanks, those are plumbed to this thing back here. This aft RCS component, aft reaction control system component to the shuttle, is the slang term for it is called the Stinger. And the Stinger is just one of the aft RCS pods. There's 2 on either side. Now, fun fact. This and this does not, you can't cross feed here. It's too complicated of a system. Why would you ever need that? These 2 feed the engine and these 2 feed the Stingers. And then on the other side of the shuttle, this is the port side ohms pod. On the starboard side pod, you have a mirror image of this. Another thing, the shuttle has another service module basically built up in the front. That's up at the nose. It's up at the nose of the space shuttle, and it's literally the same thing, only minus this part here. So you have these things up at the front, and they feed the forward RCS. So an interesting thing to understand is that none of this is cross-feedable. That's too heavy. It would have been too heavy of a system to have all these things feed off one tank, because you got to remember, these aft pods, the aft ohms pods are probably a good 100 feet. My wire keeps getting stuck in my chair. The aft ohms pods are a good 100 feet, or about 30 meters away. That's a lot of mass, a lot of extra plumbing that's pretty much, you don't need that. So it's important to understand that none of this was cross-feedable. Now, on to principle of operation. This is all hypergolic. It's all hypergolic to keep it simple, okay? What is hypergolic? So if we go back over here, nitrogen tetroxide and monomethyl hydrazine, N2O4 and MMH. If those sound like chemicals that are bad for you, yes, they are. Yeah. Don't breathe them. That would be a big mistake. They're carcinogenic. They will kill you. So if you ever come across these rocket propellants, just run away. So NTO and MMH are hypergols. So what does that mean? When they touch each other, they deflagrate chemically. The chemical reaction that you get from combining N2O4 and MMH is deflagration. They explode. They combust. That's called chemical deflagration. Literally what a rocket engine does, or a car engine, or a jet engine. Same thing. They deflagrate. So they explode. So all you need to get that rocket engine, the AJ-10, on the service module and RCS engines on the shuttle, all you need for those things to work is just some pressure. And then you need a fuel injector. That's it. The injectors on an AJ-10-190 are literally fuel injectors. They are very similar in operation to the fuel injection system that you'd see on a car. A car's fuel injection system, and all modern cars carry this, that are gasoline. Electric EV owners, just ignore this part. Just ignore this part. You don't have this. So you have a fuel injector, and the fuel injector has a little electric solenoid on it, and that electric solenoid just opens and closes. If you ever heard a car engine run, and you've ever popped the hood on a car and you're listening to the engine run, or if you have a car, go outside, pop the hood, provided you don't have an exhaust leak or anything, turn the key and then listen. You'll hear the fuel injectors going. Yes, they sound just like that. I'm good at making the noise. Be quiet. I do noises. So those injectors, what they do, they're back pressurized, and all it does is open and close a valve, and when it opens and closes a valve, it just sprays fuel. The AJ10 has 2 of those, one for MMH and one for NTO. Now, on a car, you have a fuel pump that's making pressure inside of a delivery manifold called an injector rail, right? Obviously, you don't have multiple combustion chambers with your rocket engine, so you don't have that, but you need a pressurized system. That's very important. So, how do they make pressure up in space? Use a fuel pump? So, the thing about that is if you're going to use a fuel pump, right? If you're going to use a pump for a system like this, well, take the fuel pump that's in your car, in your gas car, right? Take the fuel pump in there. So that's pumping gasoline out. So what's taking up the space of the gasoline in the fuel tank? Channeling the inner Michael Winslow, yes. Yes. So, what's taking up the space when in a car gasoline engine with the electric fuel pump, what's taking up the space that the fuel evacuates? Well, gasolines have a vent. An atmosphere comes in and takes up the spot where the gasoline is. Where the gasoline was after it goes to your engine. All cars have a fuel tank vent. You need that, or else your fuel tank, your fuel pump will actually pressurize and implode your gas tank if you don't have a vent. That's kind of important. Now, where's that vent? It's that thing that you use to put the gasoline in the car. That's your fuel tank vent. Some cars and some modern cars have a secondary vent system that is tied into the fuel filler neck, but that's another story. So, hey, Clavic61 month resub. So, how do they do that? You don't want to implode these tanks on the like when you're out on orbit. Orion doesn't want to do that. They didn't want to do that during the shuttle program, that's for sure. So, how do they do it? Well, in this area right here, there's a helium tank. Helium tank. Straight up. Helium tank pumps gas into they pump helium, or they have a solenoid, right? And the solenoid opens up and they pressurize the system. Now these lines are just pneumatic lines. They look like brake lines, believe it or not. If you look at them, they're just stainless steel bent lines, stainless steel pneumatic lines. Very similar to brake lines. Brake lines are hydraulic. It's a little bit different. So they have a solenoid that opens up. The helium tank, they pump helium into this, but there's a catch here. These tanks right here have a fuel bladder inside, or an oxidizer bladder. That's what they're called. That's what it's called. It's got a bladder inside. So think about if you had like a propane tank, right? And you took a balloon and you inflated the balloon inside of the propane tank, right? And so the balloon is pushing up against the walls of a propane tank, right? Now your balloon, you take it and you fill it up with fuel, and then try to pump air in between the gap between the balloon and your propane tank. What's going to happen? The gas is going to compress and it's going to squeeze the balloon, squeeze the bladder. These use a fuel bladder inside. So the helium gets pumped into the area between the outside of the tank and the fuel bladder, and it squeezes it, and that's how they make pressure. And then once the entire system is pressurized, all you got to do is click the solenoids on the AJ10. And then the rocket engine fires. You can pulse them, you can run them just indefinitely. For RCS, it's very useful because you're just clicking the solenoids on and off to get the RCS to go. Very easy operation. Now, why? Why do we use that? If these things are so bad for you, why do we use them? Well, we don't do that because these chemicals don't really decompose. Gasoline in a car will decompose eventually into varnish. That's no good. Or paint, turn into paint thinner, really, if you really want to know. These propellants up here, they do not decompose over time. They just sit there and they stay as a liquid. They don't freeze. They don't boil off. Nothing. So they're very good for long duration space flight. Very good, which is why we still use them today. And it's not just Orion. If you're a SpaceX fan out there, Dragon uses the same thing. In fact, Dragon's escape system uses monomethyl hydrazine and nitrogen tetroxide. The Super Dracos and the Dracos, they all use NTO and MMH. Starliner does, Dragon does, Orion does, the Space Shuttle did, the Apollo capsule did this. Soyuz uses a similar variant of this. The Soviets have their own version of hypergolic propellants. It's monomethyl hydrazine, or no, it's unsymmetrical dimethyl hydrazine and nitrogen tetroxide. They use UDMH is what it's called. A slightly different formula, but more or less the same thing. Could you actually make a car fuel tank implode by blocking the intake? Travis, the fuel pump will probably burn out before you do that. There's no way the fuel pump can create vacuum enough. You would need a really strong fuel pump to do that. There's no way the fuel pump would create enough vacuum. You'd most likely break a fuel line before you break the tank. I mean, the tanks are really strong because gas tank. How do they test that these engines would actually work in space back in the day? Well, it's funny you should mention that. Well, we got the U.S. and Russia too, and the Soviet Union. We got very, very, very intimately familiar with hypergols. Both of us, for a short period of time, used them in missiles. So there was a lot of research done. They threw a blank check at it. There was a ton of research done on it, and now it's really well understood. So we got that going for us, which is nice. Both of us, you know. Yeah, see those things down there? Hypergols. Yep. Russia even went so far, or the Soviets even went so far as coming up with a staged combustion cycle. Fuel-rich staged combustion cycle Hydrolox engine. Or not Hydrolox, excuse me, that's the space shuttle motor. A fuel-rich staged combustion cycle hypergol. Crazy, right? It's called an RD-120, I think. No, not an RD-120, that's the wrong motor. Protons rocket engines. Those are hypergol stage combustion cycle. Pretty weird, huh? Yeah. If I remember correctly, they also use the helium to purge the OMS engine after they're done. Yeah. So is the helium, the pump into the tanks, gas or liquid? Helium, Cody, it's gas. The thing about helium, and this is why it's in demand for a lot of industrial applications. So think about what we know about gases, okay? So take something like water, all right? So water exists as a liquid down here. If you heat it up, what does it do? It evaporates, right? It evaporates into moisture in the air, right? But if you freeze it, it also turns solid, right? There's not a big temperature delta between when these events happen, right? If you're using centigrade, right? If you're using Celsius, 0 is solid, 0 to 100 is liquid, and then 100 is gas, right? 100 plus is gas. The thing about elements is that every one of them can either be a solid, liquid, or a gas. True story. Some of them really, really, really don't like doing that. Okay? So, think about it. Hydrogen. Hydrogen does not like being a liquid. It really doesn't want to exist as a liquid, especially down here. It's too warm. I mean, you saw the pipe that Trent, Chad, and Billy, the red team, NASA's red team went out and they torqued that pipe. You saw how cold that thing was, right? It's because hydrogen only really likes to exist as a liquid at minus 300 C or something like that. And the window for it, just like there's a window for H2O, right? The window for it is like maybe 5 degrees centigrade, maybe. So you go too far in one direction, you go too far off those 5 degrees, gas. But here's the thing. There's an even smaller window for hydrogen to exist as a solid. It's less than a half of a degree of Celsius. Or, maybe 0.1 Kelvin or something. It can exist as a solid. It's possible. But to get the conditions to do it and keep it stable is really, really, really freaking difficult. Now, hydrogen's really sweet. It's really sweet because it's really reactive. It conducts heat very well, and when combined with an oxidizer, it explodes really, really well. Right? Helium, believe it or not, is like a distant cousin of hydrogen. It's not too far off. But here's the thing, and Cody, this is what you got to understand about helium. Helium can do everything that I just said, but it's inert, non-reactive, and extremely conductive of heat as well, because it's hydrogen's distant cousin. Interesting, right? So think about the applications there for something like helium. Helium can chill around in the vacuum. You can outgas helium into space and it doesn't solidify. Weird, huh? It'll just gas. The industrial applications for helium are insane. That's why it's so sought after, because it's ridiculous what it does. It'll stay as a gas no matter what the temperature. It'll stay as a gas all the way down to vacuum almost, which is unreal. There's not many things that do that. There's not many things that are inert that do that. So it's non-reactive, but helium is also super conductive of heat. So think about the applications there. You can have a helium heat exchanger, and you would not have to worry about the system getting jammed up by getting too cold or too hot, because it always stays as a gas. Minus 420. Yeah, good number. Interesting, right? So they use helium in these things because they know helium is going to work, and it's super freaking simple. And when the thing about spaceflight is that spaceflight is not, there's no particular system on a vehicle, maybe save for the rocket engines, like first stage, second stage rocket engines, like the things that you use to get up there. There's no system on a spacecraft that is inherently complicated. A spacecraft is just a bunch of these simple ideas being put together. And the simpler these ideas can be, when the whole thing comes together, you have a net higher simplicity, right? It has to be simple. You have to keep it simple with spaceflight, or else if you try to create a Rube Goldberg spacecraft in space, it's gonna probably explode. Yeah, that's usually the net result. Pretty crazy, right? Anyway, let's get our shuttle back down and start working on our station modules. You have to keep it simple with spaceflight. That's so important. Okay, Ohm's burn is complete. Okay, lock out the gimbal, shut down the motors. Gimbal's locked out, motors are good to go. Are you going to take the break? Yeah, we can do a garage stretch break. That's fine. We can do a garage stretch break, and then we'll get that shuttle back down. And then I gotta design some, we gotta start putting together some station modules, dude. We'll start messing around with our space station ideas. Check my and GrabShark's last links for diagrams for temp and pressure. Yep. Oh yeah, there you go. Very nice. Hydrogen and helium phase diagrams. Yeah, crazy, right? Made the Lockheed lander. Ooh, very good. All right, ARJ, let's do that garage stretch break, shall we? Can we start with the Jello module? No, I hate Jello.
Testing, testing, testing. Are you picking up the garage stream?